So we learned in the last lecture video that binomials that are a difference of squares are the easiest factoring you're ever going to see. You just take the square root of the first thing, take the square root of the next thing, and you make one a sum, one a minus, you're done. Right? They're conjugates of each other, and it's wonderful. And then we learned that the sum of squares is prime, so we're not really going to mess around with that too much. Now we're going to move on to cubes. So there's the sum of cubes and there's a difference of cubes. And this is a formula you do not have to memorize. This is one that is given to you on your exams because nobody needs to memorize this stuff other than your math teachers. Right? So it's a plus b parentheses and then quantity parentheses a squared minus ab plus b squared. All of that together makes, there we go. And then I'm actually going to copy that. That's the sum one. And then the difference one looks identical practically, except it has the minus and the plus reversed. There we go. Now again, this is not a formula for memorization. Instructors generally don't make you memorize this. It's given to you on the formula sheet on the final exam. But it's useful because we run into cubes a lot. Okay, so we have x cubed plus 27 on this problem. What we want to figure out is what's our a and what's our b. So remember the formula is, and I'm going to write it out here. I'm going to bring it down into this problem so you can see it. So the formula is a cubed plus b cubed. That's what we got. We've got x cubed plus 27, right? So you figure a is x. That's not too hard. Now b cubed is 27. So what does that mean b must be? B must be equal to 27 to the 1/3, oopsie, 1/3 power. Oops, that didn't work out. 1/3 power, which is equal to, and we know that also as the third root of 27. We learned all of that in chapter 4, and that's 3. Okay, so there's my a, there's my b. My a is x, my b is 3. Now I'm going to substitute into the lovely formula. You don't have to memorize it, you just got to use it. So x cubed plus 27 is, parentheses. So I'm going to put a plus b, that's x plus 3. Next parentheses. Hold on. A squared, so that'll be x squared, minus a times b, that's minus 3 times x, plus 3 squared, which is 9. And you're done. That's all there is to it. This part in the back, this back parentheses, is not factorable. It's never factorable, so you don't have to worry about it. You're always done once you've used the formula up, as long as there's no GCF to take out in the first place. Cool. All right, let's do it again. Okay, so the next one's going to be a difference one. Let me bring it up. So it's a cubed, a cubed minus 125. All right, so let's see here. A is a. Capital A is equal to little a. That's kind of obvious. So not too hard on that one. And then b cubed is 125. So that must mean, let's see, b cubed is equal to 125. So that means that b is equal to 125 to the 1/3 power. And that would be the third root of 125. Which we learned in chapter 4 is 5. Although you can find it with a calculator as well, right? All right, so there we go. We've got our two pieces. We've got little a is capital A, right? It's a little confusing. And then little capital B is equal to 5. So we're going to take our formula and we're going to fill in those pieces. So little a minus 5. There's the first part. Then little a squared plus 5a plus b squared, which would be 25. And you're done. That's all there is to it. The only work you could possibly show is finding what your a and b are, and then you just substitute in the formula. And again, instructors don't make you memorize that formula, so don't stress. All right, so let's do it again for this one. Now this one's going to be a little bit more complicated. So we got a cubed, and see, we got 8x cubed. That's our first one. And then we have 27y cubed for the back. Okay, so that's going to be a little bit more complicated. Let me make this go away. So let's think about this for a second. A is what? All right, so a cubed is equal to 8x cubed, right? So let's think about that. We need to have both of those raised to the 1/3 power. So to find what a is, what you're really finding is the third root of 8x cubed. Or if you will, you're taking it to the 1/3 power. That would be 2x, right? We learned that in here, 8x cubed to the 1/3. There you go. So you're saying, okay, I need 8 to the 1/3. 8 to the 1/3 is 2. And then with these ones, you multiply the powers. 3 times a third makes x, right? So there you go. You got your a is 2x. And I'm kind of making it more complicated than it really needs to be. I mean, it's sort of obvious when you look at the problem what it must be. I think it is, but if you don't find that so, then that's fine. You can use this. So for the next one, b cubed is 27y cubed. So that means b must be equal to 27y cubed all to the 1/3 power. Okay, well, again, that's going to be pretty obvious. That's the third root of 27y cubed. And again, either way you want to think about that, that's fine. If you want to do cubed to the 1/3 power, or you want to do the cube root, it's fine. You'll get it right anyway. It's 3y because the cube root of 27 is 3, and then the y to the third and the 1/3 power will cancel each other out and make 3y. All right, so we've got that part. Now that we have that, all you have to do is substitute in the formula, and you got it. So you've got 2x, so 2x, take away 3y. There's a, take away b. Then you have, now here's where it gets fun. You have a squared, so that's 2x squared. What is it? Plus ab, so plus 2x times 3y. This one's actually going to have some work for us to do. There we go. Sorry. And then plus 3y all squared, because you want to square all of b. It says take all of b and square it, so I want all 3y squared. All right, so this is going to be 2x minus 3y. I'm sorry, I was messing around with my formatting here. All right, so it's going to be 2x minus 3y, just like it was before. Nothing's changed on that part. And then you want to take the time to figure out what these other pieces are. So 2x squared, that would be 4x squared, plus 6xy, because 2 times 3 is 6, plus 9y squared. There we go. It's not really hard, it's just tedious, right? And you can't forget to square the 2. That's the big mistake people make, is they'll forget to square the 2. They'll just make 2x squared, but it's 4x squared because 2 times 2 is 4. You have to square all of a. And then here you have to square all of b, so that makes 9y squared. All right, next. So we have end of the fourth, take away 60, or end of the ninth, excuse me, take away 64. All right, so hold on one second. Okay, for this one, we know that a cubed is equal to n to the ninth. So that must mean a is n to the ninth to the 1/3 power, which would be the third root of n to the ninth. And that would be n cubed. Correct? There we go. All right, so there's our a. And then we know b cubed, oops, capital B cubed is equal to 64. That's part pretty easy. So, oops, my bad. There we go. Messing up all over the place. Okay, so then b is equal to 64 to the 1/3 power. Oopsie, messing up. There we go, 1/3, which would be equal to 4. Right? Oh, I suppose if you're a person who likes roots, that's fine. It's 64 to the third. We're going to deal more with roots in chapter 9, but if you're a person that deals with roots better than the fractional powers, they're one and the same, so whichever way you want to write it. Okay, so then we have our parts for our formula. So we're going to write a minus b, so that's n cubed, take away 4, and then a squared, that'd be n, I better put in parentheses. I want n cubed all squared. I'll figure that out in a minute. Plus 4 times n cubed. You just multiply them. That's easy. Plus 4 squared. Okay. So all I got to do is finish this part out. And then box it. So n cubed minus 4. I can't do anything more with that. If it was an 8, I'd have to keep going because 8 is a perfect cube. But 4 is not a perfect cube, so I'm done there. And this is n to the 6, right? We learned that back in chapter 4, that 3 and 2, when you raise a power to a power, you have to multiply. And then 4 squared, we all learned a long time ago, is 16. And you're done. So there's how to do cubes, and there's how to do squareds. So remember, for cubes, you don't have to memorize the formula. They'll just be given to you. You just have to apply them, right? So the sum formulas, the difference formulas, the formulas themselves take care of all the minuses and pluses for you. Everything's great. So we've done those, and then we did the easiest factoring you're ever going to have, which is the difference of squares. When they're both perfect squares, when there's subtraction, easy. And when they're summed, then it's prime, and you can't do anything if they're both squareds. All right, we're done with 6-5, part 1. I'll meet you back here for a roundup of all the factoring that we've had.